Okay, so in this question, if you're completely not sure where to start, I've put some parts from the textbook up to the right-hand side just so that you can read through that first, try and make this make a bit of sense. The most important thing that we want to take away from what it said in the textbook, though, is that the position of any point on this line can be calculated by adding scalar multiples of d to the initial position vector A. Now, in our equation over here, this is our initial position vector of A. You can see it takes that same spot as it does in our vector equation of a straight line. So, if we're adding scalar multiples on, we should get one of these answers. So let's start doing some maths. Now, the first thing we're going to do is set them up in parametric form. So x should be equal to 0 plus 4 lots of some scalar value. Y should be equal to 7 plus 16 lots of some scalar value. And z should be equal to 13 plus negative 2 lots of some scalar value. Now, for the first statement to be true, for us to get this 0 here, the value of k must also be 0. Now, I can test to make that true by putting this one here, that 0, as my k value. 0 is equal to 0 plus 4k, and you can see that I would solve for k would have to be equal to 0. If I substitute that in, though, the first statement will give me 0, the second statement will give me 7, and the third statement will give me 13. So that doesn't align to our first possible solution. Now we're going to go through with B. So for B to be true, let's substitute it in and double check. So Y would have to be equal to 15 is equal to 7 plus 16k. No, that's not how that's done. Okay, so in B, for this statement to be true, I'm going to substitute this in to our x position. So 2 is equal to 0 plus 4k, therefore k must be equal to a half. So if I substitute that in now, I'll get 2. Then I'll get 7 plus 8 will be 13. And then I'll get, sorry, that's 15, my bad. And then z will be 13 plus minus 1, which will give me 12. So those three match up with this one. I'm going to show you how to test for C as well. It's going to give me the incorrect answer because the answer is B, but just so that you can clearly see what we're doing. So I'm now going to substitute 4 in as x. So 4 is equal to 0 plus 4k. Therefore, k must be equal to 1. Now, if I substitute k into that first statement, I'll get 4. If I substitute k into the next statement, I'll get 22. If I substitute k into this statement, 23 for that one. And if I substitute k into this statement, I will get 11. So that one doesn't match, but that's how I do it if I needed to keep testing.